this is kind of arrangement given. This represent hatching is just representing that they are fixed. Now at particular this there is one spring which is attached with this block A. Along with it there is another spring which is attached with the block B. Now it has got 280. Now it is very simple question because extension is already given, and if we know the extension we can simply find out the forces. So it is 280 millimeter and length after stretching. Okay, I am not taking as first as a support on which there is a spring attached. Okay, because I am considering the length only. Here it is given as 300 millimeter. Okay, now what is to be done? Now K is given as 1000 Newton per meter, and what else is given to me? That is 250. Okay, natural length of both the spring is 250 millimeter. What is asked to me? Mass of the blocks A and B. Okay, let me consider this as a MA and this has got mass MB, and if they are in the equilibrium the net force must be equal to 0. Okay, now first I need to consider that particular that is free body diagram of block A. Of course there will be one force, that is MAZ. Okay, MAZ, apart from MAZ there is going to be one force in the along the spring, this particular. Okay, see, this is say we say for the first spring and this we say as the second spring. Okay, because we are going to see the forces on A because of 1 also, because of 2 also, and the forces will be different because of the extension is different in both the springs. Okay, now see, this is going to be the force offered by spring 2 and this is going to be the force offered by spring 1. Okay, so you just consider this particular mass A. There is one gravity, there are 2 springs, so springs are going to exert forces in this along their position. Now there is one more surface is there, and if there is some inclined smooth, okay, if it is given as smooth then there is no friction, so there is going to be only normal reaction on A. Okay, now we better need to understand that in the cases of incline, because I know that the force on the member A is 0, and how to make sure that the force on a member A is 0 or block A is 0? If it is a 2-dimensional system, we are going to make sure it by taking forces in the 2 mutually perpendicular direction equal to 0, but it is a case of incline, so we are going to take one along the parallel to the incline and another is perpendicular to the incline. So because that is easy to solve out, so because we are known with the angles here. Now I hope you all understand this angle will be 30 degree, this angle will be 30 degree. Apart from this, angle perpendicular to the incline basically is 30 degree. Now here is going to be the K stiffness of this particular spring, and x2 is the extension of spring 2, and here is going to be, this is also along just the same direction, just collinear, that is force K x1. Why K only? Because the spring constant is for both of them is given as equal. Now from here we have 2 equations, that is that MAZ cos 30, it is going to be MAZ, because see, if I am going to consider in 2 mutually perpendicular direction, better I need to take in the perpendicular to the inclined and parallel to the inclined. These 3 forces are already in those 2 directions. Now this MAG is not in this, neither perpendicular to the incline nor parallel, so better to take the component. So MAG will have 2 component, one cos 30 perpendicular to the incline, one sin 30 parallel or down the incline. So that is MAG cos 30 will be equal to NA. This is our first equation. Okay, now from this, here there is going to be forces. See, this Kx1 is in the up the incline. This has to be equal to Kx2 plus what? Plus MAZ sin 30. That is the only case, because they are acting down the incline, so they must be equal to the up the incline force, then only the net force will be equal to 0. And what is x1, what is x2? X1 is given as, now it is its natural length is 250, and extended length is 300, so it is going to be 50 millimeter. So better you take it as 0.05 meter, because K is given in the 1000 Newton per meter. So better, so we must find out forces in the SI direction, SI units, that is in Newton. So better to take it as in the meter. And what is x2? X2 is going to be that is again 250 was the natural length, and now it is 280. So 280 minus 250, that is going to be 30 millimeter, and it is 0.03 meter. 0.03 meter. Okay, x1 x2 has come. This is first equation, this is second equation. Here is how many unknowns? Na is one unknown, okay, and Ma is second unknown, and K is known, x1 is known, K is known, x2 is known, Ma is unknown, G is known, sin 30. Two equations, two unknown. Can't you find out the forces? Can't you find out the Na and Ma? Okay, if you do not wish to find out Na, do not find, but at least find the Ma. So just put down here that after solving this particular, it will come out as this Ma from here, Ma will coming out equal to, after solving this, 4.08 kg. Okay, now let me do this particular for a B also. I am going to draw the free body diagram of B also. Again there is going to be one force MBG, vertically downward direction, one normal reaction, and apart from this, see, there is normal reaction exerted by inclined gravity force offered by earth, and this is one spring. So spring is going to exert, that is pulling force, because see here string is, this particular string one is stressed, extended, elongated, so it is going to exert force in such a direction on whatsoever mass it is going to come in contact with, so that it will come into the natural position. So it will exert in this up the inclined position to this particular joint member A, and on this particular your fixed point, it is going to exert down the incline. If we talk about the spring 2, it is extended also, so it will try to exert force such that it will come into the natural length. It is extended, it will try to exert force on, say here it is in contact with this mass, and here it is with this mass. So it will exert such that it will come into the natural position. So it is exerting force on Ma in the down the incline that we have shown, and here it is going to exert up the incline. So it is going to be K x2. There is no other force, and this angle is again going to be 30 degree. Now NB is going to be mg cos 30, first equation again for this particular B, and now Kx2 will be equal to mbg sin 30, that is second equation. mbg, see mbg will have two components, one the down the perpendicular to the incline, and that will be parallel to the incline, parallel downwards, so down the incline. So kx2 will be equal to mbg sin 30. How many unknowns beta? See, x2 is known there only, so k is known, mb is one unknown, nb is one another unknown, two unknown, two equation. Can't you find out? Yeah, simply we can find out. So that is going to be and see, if we calculate mb from here, it will come out as 6.12 kg. So what are the options? This is 4.08 and 6.12. See, it is matching with the option C.